Question number 6 of 2023 CSAT. Let's look at the question. What does it say? Saying there are 4 liters and 5 envelopes. So we call such type of problems as sometimes derangement problems. The question is saying that there are 4 liters and 4 envelopes, and exactly 1 liter is to be put in exactly one envelope, as in one-to-one mapping you will have to do with the correct address. Envelope will have address written on it. If the letters are randomly inserted into the envelopes, then consider the following statements. It is possible that exactly 1 letter goes into an incorrect envelope. And the second statement is there are only 6 ways in which only 2 letters can go into the correct envelopes. So we have been given 2 statements. We have to figure out if they are correct or wrong. So let's start the process of thinking. The approach to the problem. So how should we start thinking about such kind of problems? Here, to help visualize the problem, what it is saying, we can simply name the letters as L1, L2, L3, L4 being 4 different letters, right? Imagine this like you have Shadi ka card and you have envelope, probably not Shadi ka card, maybe personalized. You can think of personalized Shadi ka card, right? So personalized different Shadi ka card as letters, and you have envelopes corresponding to each of the letters with address written on the envelopes. So we have personalized Sadika cards, 4 personalized Sadika cards, and address written. So if so address will be different addresses for 4 different people. So we call these envelopes as E1, E2, E3, E4. Now that you have visualized this problem, let us start solving this. In this sort of problem, what you are usually asked is in how many ways you are misplacing M letters, right? So this is the kind of problem, the question you are asked in this sort of problems. How do we solve this kind of problems? Again, we are not going to use derangement formula from J concepts. We'll simply take different cases and solve this question using our aptitude. So there is, if I ask you how many ways can I correctly put these letters into envelope, 4 envelopes. So there is only one way, right? Only one way to have correct mapping. L1 map goes into E1, then L2 goes into E2, then L3 goes into E3, then L4 goes into E4. So there is only one way to correctly put your letters into correct envelope. Now just look at this diagram and tell me, is it possible that exactly one letter goes into an incorrect envelope? Is it possible? Because you have the same number of envelopes and letters, then if you put one letter in a wrong envelope, then the letter of the wrong envelope, the letter that is of the wrong envelope has to go to the other envelope where the first letter did not go, right? So if I, let's say, put this L1 into E2, L1 into E2, then L2 will have to find some other place, other envelope, because it cannot go into L2 now, E2 now. So, and wherever L2 will go, for L2 it will be a wrong envelope, right? Wherever L2 will go, for L2 it will be wrong envelope. So minimum derangement which is possible is of 2 letters. L2, let's say, is not going to L3. L2 is going to E1. Sorry, L2 is not going to E3. L2 is going to E1. So minimum derangement is 2. You cannot have a scenario where only one letter is in wrong envelope. There has to be 2 letter, right? Because the letter which you are picking up first to put in a wrong envelope, the letter of the second envelope in which you put the first envelope has to find some other envelope, because cannot go to the same envelope. Hence it is the second envelope letter will also go to a wrong envelope. Hence it is 2. You cannot have only one letter, exactly one letter, into a wrong envelope. You will always have at least 2 letters in wrong envelopes. So first statement is wrong, right? Coming to second statement, there are only 6 ways in which only 2 letters can go into correct envelopes. So we have letters as L1, L2, L3, L4, envelopes as E1, E2, E3, E4, right? We have to count all the cases, possibilities, all the cases, possibilities where exactly 2 letters have found their place. in the right envelope. Right? So we have 4 letter, 4 envelope. First, we assume that L1 and L2. Let's say L1 and L2 first. Right? They have found the right envelopes, which is E1 and E2. Then you are left with L3 and L4. They'll go into wrong envelopes. Then let's say, so how would you count it? Just give me just let me change slightly the approach. The explanation which I would have given through that way would have been a little complex. Let us simplify a little and move forward. We have letter 1, letter 2, letter 3, letter 4. We'll pick all the correct ways of putting 2 letters corresponding of putting 2 letters in correct envelope. First, in the first case, what I am going to do is I am taking L1. That L1 is in right envelope. I have to pick now the other letter along with L1, which is in right envelope. So along with L1, it could be L2, it could be L3, it could be L4. So you have 3 ways here. Next case I am considering L2 is in right envelope. Look at this. When I am taking L2, I'll not take L1 because L1 and L2 I have already considered. So I'll take others which are coming after L2. I'll take others which are coming after L2 because L1 I have already taken along with L2 in the previous case. So in this case, L2 along with L3 and L2 along with L4. These 2 ways. In third case, see, the previous one is already being taken care of. When I am saying taking L3 and I am trying to get another letter for which I am making the pairing with L3. So I'll not be taking L1 and L2 because L1 and L2 have already made the pair with L3. So I'll be taking whatever is coming after L3, which is in this case L4. So one way. Sum them up, 6 ways to put exactly 2 letters in the wrong envelope. So second statement here is correct. Second statement is correct. You have answer B.